Points P, R, S, and Q, T, U are on the parabola with the equation y is equal to x squared minus 1/5 mx plus 1/5 n, so that PQ equals 13 and the slope PQ is 12 over 5. For how many points Mn of positive integers with n less than or equal to 1,000 is R plus S plus T plus U equal to 27? Let's just draw a very brief diagram, and perhaps this parabola looks something like this, and we've got to choose 2 points here, P and Q. And when we draw a line from them, they're going to say that that slope is 12 over 5. So this is just to illustrate what that looks like. And therefore, we can now calculate using the points. P is RS and Q is TU. So using those 2 points, since the slope is equal to 12 over 5, we can use those 2 points to get a little equation. So U minus S over T minus R will be equal to 12 over 5. And I have no idea what is U and S and T and R, but I know the ratio. So that means U minus S must equal some multiple of 12, and T minus R is probably some multiple of 5, and that's how you get a ratio of 12 over 5. Okay? All right, so that's the first little piece of mathematics. Now the next thing is this piece of information right here, that the distance between P and Q is 13. So using the distance formula and those 2 points, we can find the following equation, that U minus S squared plus T minus R squared is equal to 13 squared, right? So I'm going to substitute these points in to figure out what K could possibly be. U minus S is 12K, square that. T minus R is 5K, square that. And I've got 169 here. So this becomes 144K squared plus 25K squared, and that is equal to 169. So this is now 169K squared is equal to 169. So that means obviously K is equal to 1. All right, great. So putting that back into these two guys, that gives me that U minus S is equal to 12, which would be giving me U is equal to 12 plus S. And then it gives me that T minus R is equal to 5, which would give me that T is equal to 5 plus R. So my 2 points now, I have P, R, S, and I have Q, T, U, but what I can do is I can put Q in terms of R and S, since I have these 2 relationships right here. That will allow me to put T as 5 plus R and U as 12 plus S. So there we go. That at least helps me a little bit. I can get rid of some of the variables, and now I can work with less variables, which is always better than more variables. Okay, so here we go. Now let's turn our attention to this part of the question. They want us to figure out a situation where R plus S plus T plus U is equal to 27. All right, but I know some really nice relationships here, so let's substitute those in. That T is equal to 5 plus R and U is equal to 12 plus S. So I've got R plus S plus T, which is 5 plus R, plus U, which is 12 plus S, is equal to 27. So this simplifies to 2S plus 2R is equal to 10, and therefore S plus R is equal to 5. So that's my first piece of information that is very helpful. Now both those points P and Q are on the parabola, so we can substitute those points into those parabola. So substituting, we get the following. We get the first equation, which would be substituting this point, And that would basically give me S is equal to R squared minus mr over 5 plus n over 5. And then substituting that one, we get a little bit more algebra there. We get S plus 12 is equal to 5 plus r squared minus m times 5 plus r all over 5 plus n over 5. And then when you expand this, you get S plus 12 is equal to r squared plus 10r plus 25 minus m minus mr over 5 plus n over 5. And then what we do now is we will subtract from 2 equation 1 and simplify. And when you collect like terms, you will get just 12 is equal to 10r plus 25 minus m. Simplifying and isolating for r, you get m minus 13 over 10 is equal to r. So this is my next helpful piece of information. Now I will take this very helpful piece of information and I will substitute it back into 1. Equation 1, that is, right here. And when I do and I put that in, I get m minus 13 over 10 all squared minus m times r, which is m minus 13 over 10. And then, of course, don't forget the 5 there. And then plus n over 5. Once you simplify this big, long thing, you get the following. You get S is equal to 1 over 100 times minus m squared plus 169 plus 20n. This is another very helpful equation. So, to summarize, we now have 3 very important equations that I have placed a star. We have S plus R is equal to 5. R, this guy, is equal to this. S here is equal to this. So I will put what I have for R there and what I got for S right there. So that's my next step. R plus S is equal to 5. So let's put R, which is m minus 13 over 10 there. S is over here. Let's put that over for the value for S. So it'll be 1 over 100 times minus m squared plus 169 plus 20n is equal to 5. Okay, so now we have to simplify this. And when you simplify, you get 20n is equal to m squared minus 10m plus 461. If you complete the square, you will be able to factor this very nicely. And you get 20n is equal to m minus 5 squared plus 436. All right. So now let's talk about this now. This is the equation that pretty much we're down to. This is our sort of final equation that we need to talk about and discuss and all that stuff. Well, 20n is obviously an even number. 436 is an even number. So that means this guy has to be even. And therefore, m minus 5 is even. And therefore, m is odd. Okay? So I hope that made sense. So since m is odd, I will let m equal to an odd form, which is 2k minus 1. Right? Any odd numbers of that form. And I will now substitute that back into this guy right here. All right? So substitute m is equal to 2k minus 1 back into my equation here. So when I do that, I get 20n is equal to 2k minus 1 minus 5 all squared plus 436. When you simplify and collect like terms, you get 20n is equal to 4k minus 3 squared plus 436. And I can divide through by 4, and that just gives me 5n is equal to k minus 3 squared plus 109. All right. Now recall that n in the question was given to us as being less than or equal to 1,000. So we can use that to help us out. And what I'm going to do is make a little table and try to figure out how can I make this equation here work. Well, we need to first consider values for k minus 3, then values for k minus 3 squared, and then of course the entire equation, which is k minus 3 squared plus 109. Now, k minus 3 squared plus 109 is equal to 5n. So that means that is a multiple of 5. And multiples of 5 end in either 5 or 0. All right? So what I'm going to do is I'm going to place only the units digit into those boxes to figure out what my k can be. Well, k minus 3, whatever it is, the units digit is anywhere from 0 to 9, right? Those are all the possible units digits. Okay, if that is the case, when I square it, what happens? Well, the units digits then become 0, 1, 4, 9, 6, 5, 6, 9, 4, and 1. Okay, what happens when I add a 109? Well, then the units digits become 9, 0, 3, 8, 5, 4, 5, 8, 3, and 0. Well, which one of these end in either a 0 or a 5? This one, this one, this one, and this one. So that means that k minus 3 has to have a units digit of either 1, 4, 6, or 9. All right? Okay, so since my n is less than or equal to 1,000, don't forget about that, a very important parameter. That means that k minus 3 squared plus 109 is less than or equal to 5,000, since it's equal to 5n. Correct? So that means that k minus 3 squared is less than or equal to 4891 when you subtract the 109. And when you take the square root, you get k minus 3 is less than or equal to 69.9. But remember, k is an integer. So k minus 3, I should say, has to be less than or equal to 69. K minus 3. Now we have to talk about what values of k can I plug in that will give me units digits of either 1, 4, 6, or 9. Correct? And keeping in mind that k minus 3 is less than or equal to 69. So I got 72, 69, 67, 63, if you notice, if these are k's, k minus 3 will equal numbers that give these as the units digit. Okay, that's what I'm doing. So continuing, I get 62, 59, 57, 53. You'll see that there's a pattern here. 52, 49, 47, 43, and so on, right? So I'll just fill them all in. And there you go. There's my entire list, where k minus 3 is less than 69. And I'm choosing values of k so that k minus 3 will have a units digit of either 1, 4, 6, or 9. And how many did I create in total? If you add all those up, it's 29. And each value of k from this list of 29 will give one value of m, because if you recall, m is equal to 2k minus 1. And then once you have a value of m, you plug it back into here to get a value of n. So each of these 29 values of k will give a value of m and a value of n. Therefore, that would give me 29 pairs of the form mn. And that is the answer to the question, 29. So that would mean that number 25, the answer is D. Consider the quadratic equation x squared minus r plus 7x plus r plus 87 is equal to 0, where r is a real number. This equation has two distinct real solutions x, which are both negative exactly when p is less than r, which is less than q, for some real numbers p and q. The value of p squared plus q squared is. We have x squared minus r plus 7 plus r plus 87 is equal to 0. Now, we have to find two solutions, first of all. So that means the discriminant cannot be 0, and I'll talk a little bit about that later. Both of these solutions are going to be negative. Okay, so those are some important conditions that we have to keep in mind. So let's just go ahead and do the quadratic. So that would be r plus 7 minus b plus or minus the square root of b squared, r plus 7 squared, minus 4ac. A is 1 and c is r plus 87. And that's all over 2a, but a is 1. Okay, so this is r plus 7 plus or minus. When you expand this out, you get r squared plus 14r plus 49 minus 4r minus 348. All over the square root sign, and this is all over 2. So let's see here, r plus 7 plus or minus. When you combine this, we get r squared plus 10r minus 299. Okay, so this is the discriminant right here, and I'll write it out. And I had previously mentioned the discriminant in this case has to be greater than 0. So r squared plus 10r minus 299 has to be greater than 0. If it was equal to 0, we would only get one root, and we need two roots. So let's work with that. R squared plus 10r minus 299 has to be greater than 0. So what I want to do is get an understanding of when is this graph greater than 0, for what values of r. And I think I'll be able to do that without too much problem by doing a quadratic once again. And can this factor? If it can factor, I wouldn't need to do a quadratic, and I think it can. 23 and 13, I believe. 23, 13, R, and in terms of the signs, plus for 23 and minus for 13. Okay, so let's just do a basic sketch. So that means when R is 13 and negative 23, those are the roots. And because this is a positive coefficient, it's going to open upwards. So basically the graph is something like this. Something like that, right? So that means it's above 0 when r is either greater than 13, as you can see here, or when r is less than minus 23. All right, so that's very helpful. So now what I have to do is go back to my original equation, which is right here, and try to satisfy the next condition, which is that both have to be negative, both the roots. I've looked at that and I've figured it out that there's two solutions when r is in those ranges, but now I've got to satisfy what is r in order to make both of the solutions negative. Okay, so I've got to get both of these negatives. Now I don't know, so I'm going to just pick one and see what happens. So I'm going to start with this one. R is greater than 13. Okay, let me choose r equals 14. Let's see what happens to the roots. So x would be therefore 14 plus 7 plus or minus 14 squared plus 10 times 14, 140 minus 299, all under the square root sign, all over 2. So that's going to give me 21 plus or minus, what is this? When you do the math, I think it becomes 37 over 2. And this gives me, both of these are going to be positive. One's 13.5 approximately, the other one's like 7.5 approximately. Okay, well, that didn't work. So it must mean that r is less than 23, but just to be sure, let's see. Let's choose a number that's less than 23, minus 24. And let's see what happens. So plug it back into this equation. Minus 24 plus 7 plus or minus 24 squared minus 240 minus 299, and that's all over 2. So x is going to be minus 17 plus or minus, and this becomes 37 root again, interestingly. So this gives me roots of minus 11.54 and minus 5.46. So there we go. We got two negative roots. So I am going to conclude that r is less than minus 23. All right, great. So r is less than minus 23. So this basically means that q is minus 23. I'll just write it up here. R is less than something and greater than something. Well, I just proved it's less than minus 23. So I got the value for q. Now all I have to do is figure out what is it greater than, and then I can easily figure out q squared plus p squared. How do I do that? Well, we can just use the same. We are told that these have to be negative. So all I have to do is set that less than 0. And once I do, I can get a understanding of what r is in terms of what is greater than. So let's do that. Let's just keep that in the screen, and let's set that less than 0. So r plus 7 plus or minus the square root of r squared plus 10r minus 299 all over under the radical divided by 2, that has to be less than 0. And we had done that earlier. The only thing is we had done it for actual specific numbers. But I don't want to do it for any specific numbers. I would like to do it for just r. So here we go. Multiply through by 2, and you just get r plus 7 square root of 2, r squared, 10r minus 299 is less than 0. Now at this point, I'm going to compare a little bit to make it a little bit easier to understand with what I did over here. So for example, the r plus 7 is represented here by minus 17, right? So I'm just going to put that in there just so you know what's kind of happening here. And then this part, the radical, was this guy, root 37. And that has to be greater than 0, right? So continuing with the r's, what I'm going to do is put that on the other side. So r squared plus 10r minus 299 square root. So that basically means that you have this plus or minus still, But really, it's still a comparison between something like minus 37 and root 37. And minus 17 is less than plus or minus root 37. If it's plus root 37, it's obviously less. And even if it's minus root 37, it would be less. Now, here's the part of the question that we need to pay close attention to. I want to get rid of that radical sign. And when I do, obviously, I square both sides. When I square the right side, it just becomes r squared plus 10r minus 299. When I square the right side, that's what I get. When I square the left side, it'll be r squared plus 14r plus 49. But here's the thing. I have to switch this symbol from less than to greater than, because now, remember, I put these in for a reason to illustrate what happens. When you square, because this number was negative, it becomes 17 squared. This squared becomes 37. So as you can see, it's greater than. So that's why that sign had to be switched. Now at this point, it becomes relatively easy. The r squareds cancel from both sides. I can bring the 10r over, so this becomes 4r is greater than minus 299 divided, minus 299 subtract 49. So that gives me minus 348. Divide through by 4, and it will give me minus 348 divided by 4 is minus 87. There you go. R is greater than minus 87. So I go back, and that's exactly what I needed. I needed something that R was greater than. So R is greater than minus 87. There you go. I just got that inequality. Now they want p squared plus q squared. Well, this is my p, and this is my q. So p squared plus q squared is just minus 87 squared plus minus 23 squared. And that is equal to 8098, conveniently right underneath. So the answer to number 24 is E. Suppose that a, b, and c are integers with x minus a times x minus 6 plus 3 is equal to x plus b times x plus c for all real numbers x. The sum of all possible values of b is. Well, let's expand this and see what we get. X squared minus 6x minus ax plus 6a plus 3. And on the other side, it's x squared plus xc plus xb plus bc. Now the x squared go on both sides, so let's put everything on one side and collect like terms. So minus 6 minus a x and 6a plus 3. And on this side, if we collected like terms, it would be c plus b x and then just bc. So that means if I compare coefficients, that minus 6 minus a is equal to c plus b, and then 6a plus 3 is equal to bc. All right, so where do we go from here? Well, I think for both equations, I could probably isolate for b, and that may help me. So let's do that. Or I could isolate for a. I've got to make a decision here. You know what? I'll isolate for a. I think that might help me a little bit better. It probably ends up being the exact same, but let's see. So I get a is equal to minus 6 minus c minus b. And on this side, it would be bc minus 3 over 6 is equal to a. Okay, so now let's equate them. Minus 6 minus c minus b is equal to bc minus 3 over 6. And then multiply through by 6, and we get minus 36 minus 6c minus 6b is equal to bc minus 3. Okay, if I can factor this, it would help me out a lot. Now, I think I can. I see some very helpful variables, but I think I'm going to have to put everything on one side first. So I'll put the 3 over here, and then the bc plus 6b plus 6c, and then the plus 36. I think this factors very nicely. So let's see here. I got b, c, 6, and 6. Yeah. Okay, very good. So now I've got to make a little bit of a table and try to figure out what values of b and c will be able to satisfy this equation. At first it might seem, well, that's not possible. You can't have two numbers multiplied together to get 3 because this seems too big. But if you use negatives, it will work, because 3 is the equivalent of 3 times 1. So if one of these is 1 and one of these is 3, it'll work out. Okay, so let's try that. Let's make this 1 and let's make that 3. If that's the case, then b plus 6 is equal to 1. That means b is negative 5. Okay, so that worked. And that means this c plus 6 has to be 3. So that means c must be negative 3. All right, perfect. So I've got 1 minus 5 minus 3. And I think you can reverse them. You can make this 3 and this 1. And that would also give you a product of 3. So that means this would be minus 3 and this would be minus 5. Okay, now at this point, do not think that you're done with the question. Keep in mind, you can also have a scenario of minus 3 and minus 1. That would also give you a product of 3. Or minus 1 and minus 3. So for this guy, you would get the following values. B plus 6 is minus 3. So that means b is minus 9. And if c plus 6 is negative 1, then that means c is negative 7. And for this one, it would just reverse, so it would be minus 7 and minus 9. So the question asks you to add up all the possible values of b. These are all the possible values of b, so let's add them up. And when you do, you get minus 5, minus 3, minus 9, minus 7. That is minus 16, minus 8, minus 24 is the sum. So the answer to number 23 is B. For how many integers k do the parabolas with equations y equals negative 1/8 x squared plus 4 and y is equal to x squared minus k intersect on or above the x-axis? So we can figure out, first and foremost, this equation, because that does not have any k's in it. So that is y is equal to minus 1/8 x squared plus 4. So when x is 0, very quickly we can figure out that that's going to be 4. And then this parabola points downward. It's going to be like this, right? How do we know that? Well, because this coefficient is negative. Now I need to figure out where it crosses the x-axis. And I do that by setting y equal to 0. And if I do that and solve for x, I will get 4 is equal to x squared over 8. Therefore, x squared is equal to 32. And therefore, x is equal to plus or minus root 32. So root 32 approximately here and here. Okay, we don't have to be super accurate like that. Now, this parabola, therefore, is going to look something like this, right? Like that. Now, we've got another one right here, which is y is equal to x squared minus k. Now, this parabola is going to point upward because the coefficient is 1 and positive 1. But then I've got this minus k. So I'm not sure where that k is. I don't know what the value of k is. So the only thing I know is that this parabola looks something like this. And the key is right here. On or above the x-axis is where they need to intersect. So on the x-axis, it would basically be like this. That is the first one. And then all the other ones above the x-axis would be kind of like this, right? And then eventually you're going to have that kind of scenario. And then the very last intersection point is right there, where the bottom of the orange parabola touches the top of the blue parabola. Okay? And we have to figure out all of these. And the condition is that k has to be an integer, which actually helps us. Okay, so let's move forward with this. The first thing, of course, is I'm going to have to make a table. I'm going to have to make a table for x and y. So x and k are what I'm interested in. So the very first thing I want to do is figure out where they intersect on the x-axis. And that's pretty straightforward, because if they intersect on the x-axis, then that means that we can figure out this value by setting x equal to root 32, right? Because that's what happens. That's the intersection point. All right, here we go. So we got to set this equal to this and then work with that. So we've got minus 1 over 8 x squared plus 4 is equal to x squared minus k. All right. Putting everything on one side, we got 4 plus k is equal to 9x squared over 8, like that. And therefore, I guess we can isolate for k, 9x squared over 8 minus 4. So first and foremost, when x is root 32, that's going to allow us to figure out when they intersect on this word right there, on the x-axis. That's a pretty straightforward calculation. That's 9 times 32 over 8 minus 4. That looks like 9 times 4, which is 36, minus 4 is 32. So k is 32. All right, so we got 1. Now we have to figure out all the integer values. For k, x does not need to be an integer, obviously, right? But k must be an integer according to my conditions in the question. Okay, well, instead of going k31, k32, 30, 29, that's obviously going to take forever. I'm going to jump all the way to the other extreme, which is when they intersect, but in the last possible way, which is the very bottom of the orange parabola touches the very top of the blue parabola. That would be the last intersection point as this parabola is going up, right? And like I said, the accuracy, don't worry about the accuracy of this diagram. These parabolas actually would not look like that. I'm sorry about that. I mean, they're not going to look like this, right? The parabola is going to look exactly the same. So if this one was like this, the other parabolas will all look the same. They would just be shifted up. See what I mean? Yeah, so I just wanted to illustrate to you that there's going to be intersection points higher up. So don't worry about that. Just concentrate on trying to find integer values for k. So there's going to be 31, 30, ... But eventually we're going to get down to the very last one. And the very last one is when we have that intersection point. So how do I figure that one out? Well, that one occurs when k is equal to minus 4. Now, how do I know that without figuring out anything in here? Well, because this equation y equals x squared is essentially just like this, and it's going up and down depending on the value of k. If k is minus 4, this becomes y is equal to x squared minus 4, which is y is equal to x squared plus 4. So that means that it would basically be right here, where this is 4 right there. Okay, so minus 4 is the very last one, and just if you're wondering, the x value when k is minus 4, the x value will be 0. Right? You can use this equation to figure that out. And therefore, you're going to have integer values all the way from k equals 32 all the way down to k equals minus 4. So minus 3, minus 2, minus 1, 0, and then 1, 2, 3, all the way up until 32. So 1, 2, 3, all up until 32 obviously is 32. And then these guys, there's 5 of those. So we have to add 32 and 7, and that's 37. 32 and 5. So there are 37 integer values for k, which allow these two equations to intersect either on or above the x-axis. So the answer, number 22, is E. Suppose that k is greater than 0 and that the line with the equation y is equal to 3x k plus 4k squared intersects the parabola with the equation y equals x squared at points P and Q as shown. If O is the origin and the area of triangle OPQ is 80, then the slope of the line is. Our line here is y is equal to 3k times x plus 4k squared. And since all lines are of the form y equals mx plus b, where m is the slope is 3k. So essentially the question is asking me to find what is the value of 3k. If I do that, I'll be done with the question. So these two graphs, this one and y equals x squared, intersect at 2 points, and those 2 points are P and Q. So let's set them equal to each other. So we have 3kx plus 4k squared, like that. And let's put everything on one side and see what we get. We get a quadratic equation. So we can use the quadratic formula to see what kind of values we get for x. So x will be equal to minus b plus or minus the square root of b squared minus 4ac. And then all over 2a. So that's going to give me 3k plus or minus. That looks like 9k squared plus 16k squared. So 9k squared plus 16k squared all over 2. And therefore x looks like 3k plus or minus the root of 25k squared, which is 5k all over 2. And when you do this math, it looks like 4k or minus k. So I'm assuming that this guy here is 4k and this is minus k. So what I'm going to do is blow that up a little bit. So let's put it down, these values. Let's graph them. So this guy here is 4k, and this is minus k, like that. And now we can proceed with the next part of the question, which is trying to figure out what is the actual numerical value of k. And we use the clue that this triangle has an area of 80. So what I'm going to do is compare the entire triangle and then subtract from it these triangles, and that should help me figure out an equation that solves for the numerical value of k. Now the first thing I think I will need, though, is I'm going to need that point. So when does this line cross the x-axis? Well, that line was 3kx plus 4k squared, and we want to know when does that equal 0. Well, let's see here. Let's put everything on one side. So 3kx is equal to minus 4k squared. 1k cancels, so 3x is equal to minus 4k. Therefore, x is equal to minus 4k over 3. So this point right here is minus 4k over 3. Okay, I think I have everything I need to look at the area now. The area is 80 of that shaded region, and that is equivalent to the full triangle. Subtract from it these two triangles, that one and this one. So the full triangle, 1/2 base times height. The base is from there to there. So that's 4k minus 4k over 3, so plus 4k over 3. That's going to be the base. The height is from here to here. And we need to, of course, label the heights. Since it's on the parabola y is equal to x squared, this point right here, Q, that point right there, is going to be 4k, and then 4k squared, so 16k squared. And then this point P is also on the parabola, so that point right here is going to be minus k, and then minus k squared, which is k squared. So going back to our 1/2 base times height, this was the base, and this is the height, and the height is the y-coordinate, so 16k squared. From that, I have to subtract this triangle and this triangle. Okay, so this triangle, that should be pretty straightforward. 1/2 base times height. This is the base, which is 4k over 3, and the height is this, which would be the y-coordinate right there, which is k squared. And then I have to subtract this triangle, and that one, 1/2 base times height. The base is easy, that's 4k. And then the height is the y-coordinate of that point right there, so 16k squared. Okay, so this is the equation I have to solve to figure out the numerical value for k. All right, so let's get rid of some fractions. Let's multiply through by 2. And then once I do that, let's add some of these fractions. So 4k plus 4k over 3, that's going to be 16k over 3. And then I've got to multiply that by 16k squared. This is 4k to the power of 3 over 3. And then this is 64k to the power of 3. Okay, I think I can, this is going to be 256k to the power of 3. And let's just multiply it through by 3 to get rid of the fractions. Minus 4k minus 64k. Okay, so that's going to be 256 minus 4 minus 64. Or I had to multiply, sorry, I had to multiply the 64 by 3 also. Forgot to do that. 192k squared. Okay, so 256 minus 4 minus 192, that looks like 60k to the power of 3. And on this side, we've got 3 times 160. So 3 times 160 is 480. 480 divided by 60 is 8. So 8 is k to the power of 3. Therefore, k is 2. Great. And at the very end, we had to figure out, if you recall, the slope of that line, which is 3k. I even wrote it over here. Well, k is 2. So 3k would be 3 times 2, which is 6. So number 22, the answer is D.